Hello everyone, myself Savin from Triple T Academy. In this video, I'm solving Dcet 2013 question paper, science questions from properties of solids and liquid chapters. Dear students, very first I'm going to start with a question. Poisson's ratio is defined as the ratio of dash. We have four options: lateral strain by linear strain by lateral strain by volume strain, and volume strain by lateral strain. So in which, suppose if you know the lateral strain, then you can easily find the right options. Dear students, we should know about Poisson's ratio. Poisson's ratio, it is a ratio of strain. So before that, basically we need to know about strain. What is the meaning of strain? So dear students, the strain nothing but it is usually denoted by a letter epsilon. That is change of dimension to original dimension. Suppose if you consider this is a circular rod in which I'm going to apply force at its end. That means if it is a force is a tensile load, that means elongating a rod. In that conditions, initially I'm going to consider this is the length of the bar or a rod in which it may increases its length. After the application of a load, it may increases to some level. That increase of length I'm going to consider as delta L. See, dear students, just you observe here, one thing I'm applying a tensile force due to which it increasing its length, that is delta L. Meanwhile, even though it decreasing its diameter, initially it has larger diameter as compared to here, it is a reduced diameter. That means that there are two things is happening. One is length is increasing. Meanwhile, in case of a circular rod, the diameter is decreasing due to that tensile force F. So, dear students, what we need to understand here is that means that here due to the application of external force the material dimension is varying, changing, in which one thing is diameter decreasing due to the tensile force as well as length is increasing. That means that the length changing nothing but that I can consider as a strain, linear strain. That means visually you are going to denote it by letter epsilon. That means change in length by original length. And another one is lateral strain, dear students. Lateral nothing but a lateral dimension other than the length. The dimensions other than the length we can call it as a lateral dimension. In this case, that is change of diameter because diameter is decreasing. So change of diameter delta D by original diameter D. Original diameter D. I hope it's clear. Next, dear students, in which you can observe here that ratio of this lateral strain by linear strain, that is we are going to call it as a Poisson's ratio. The Poisson's ratio is usually denoted by letter mu. Mu ಅನ್ನ ಒಂದು ವರ್ಡಲ್ಲಿ ನಾವು Poisson's ratio express ಮಾಡ್ತೀವಿ. The Poisson's ratio is denoted by mu and it measures the change in lateral or transverse strain over a change in linear or axial strain or longitudinal strain. So this expresses the material properties. This Poisson's ratio which measures the material properties as well as express the material ways. So here in this majorly there are different values for different materials. Different value for different material. So starts from usually it value will be just start from 0 to 0.5. The Poisson's ratio does not have any unit. It is a ratio of strain, so that it does not having any units. It's a unitless quantity. So dear students, as we know, now we can conclude that the Poisson's ratio is defined as the ratio of lateral strain by linear strain. That means lateral strain here divided by linear strain. So therefore, for this question, option A is a right one. Next, dear students, I'm going to proceed with second question. That is pressure at a depth of 100 meter below the surface of water of density is 1000 kg meter to the power of -3 is. Dear students, the question here is, suppose if you consider any container, this is I'm going to consider as a container in which I'm going to consider some amount of water, in which some amount of water, just you can observe here, that is a water here in which suppose in this height of water that is 100 meter and it has a density, the density of water that is 1000 kg per meter cube, 1000 kg per meter cube. See, by considering this pressure, we can find the pressure by considering the height of the water in a tank. Suppose you have a four option. By solving this problem, we can get a right option. See, dear students, pressure according to hydrostatic conditions, that is pressure is equal to P equal to rho GH. Just observe here. See, by using this equation, you can find the height of a liquid here in this question, that is h is equal to 100 meter. H equal to 100 meter, and the rho nothing but that is density of water 1000 kg per meter cube, that is given in your question. And next, the G nothing but 9.81. Suppose if you substitute to this one, substitute to this formula, we can find a pressure. So dear students, now I'm going to substitute here, that is P equal to rho into G into H. That means P equal to 1000 into 9.81 into H. What is H? H here is 100. So then finally, let's just multiply these two first. 1000 into 100, nothing but 10 to the power of 5. If you multiply these 1000 into 100, you will get 10 to the power of 5 into 9.81. Now we can observe here, dear students, suppose if you shift this point, I mean, before that 9.81 into 10 to the power of 5 here. That means that if you shift this point to here, that means 98.1 into 10 to the power of 4. See, just look at here. This is a pressure P. So therefore, P equal to 98.1 into 10 to the power of 4 Newton meter to the power of -2. That means in the questions, you can observe here, the option D is the right one. You have option D. So right option is D for this second question. Next, dear students, I'm going to proceed with third question. When two capillary tubes of different diameters are dropped vertically in a liquid, the height of the liquid is dash. See, just this is a capillarity on the property of liquid, capillarity properties mele ee questions ಇದೆ. Just you can observe here. Here I'm going to consider a bowl in which I'm going to consider a two different diameter of glass tubes, which are dipped in a inside the water or liquid bath. Suppose what happened in which, suppose you can consider here, this is a surface of a liquid in a container. Again, I'm going to read the same question. When two capillary tubes of different diameters, are dipped in a or dropped vertically in a liquid, then the height of the liquid is, just we have four options. First is more in the tube of larger diameter, this is a larger diameter, or more in the tube of smaller diameter, or less in the tube of smaller diameter. It may be less means here surface kinda kadime irbeku, more means more than the surface, and one more first option, that is more in the tube of larger diameter, so say here, or else the fourth option, that is same in both the tubes. So what is the right options? See, this capillarity is majorly due to the adhesive as well as surface tension properties of the liquid. On that it will be depends. So dear students, I'm going to consider this is a specific diagram in which there are different glass tubes of varying diameters. Varying diameter glass tubes are considered here, in which you can observe here, in the larger diameter the depth is only this much. Suppose if you come into the, again in the middle way, comparing all these three, something that is compared to this one, that the height of the liquid is raised in this tube. Again, I'm going to consider, I mean, comparing to this third one, in which again that height is increased. The meaning we can, by considering this, we can conclude that the height is more in tube of smaller diameter. This is due to the surface tension as well as adhesive properties of the liquid, in which the lesser diameter having a lesser diameter with that liquid, it will be having a more surface. So the reason what happened, that liquid is rises in a more in case of a smaller diameter as compared to larger diameter. So for this question, option B is a right one. Option B is a right for question number 3. Next, dear students, I'm going to proceed with question number 4. That is the property by virtue of which a liquid opposes relative motion between its different layer is. See, again we have four options: viscosity, elasticity, surface tension, inertia. Just you can observe here, dear student, these are the some of the different properties of the specific fluids or materials or any liquid. Now, what is the viscosity? First of all, dear students, the viscosity is that it is a property of fluid by virtue of which opposes relative motion between different layers. Suppose if you consider the liquid in which there are different layers, the one layer, while it is in a moving condition, I mean flowing condition, the one layer of fluid it opposes the motion of another adjacent layer of fluid. That property usually we are going to call it as a viscosity. So this viscosity again, it will be varying from liquid to liquid, even though it will be depends upon the temperature also. As the temperature increases, the liquid viscosity decreases. That is another concept. So in this question, for this specific question, I mean the property by virtue of which a liquid opposes relative motion between the different layer, this is viscosity. The viscosity, dear students, visually we are going to denote it by letter nu. That is the force of friction F is resisting the relative motion between two layer. That is viscosity. For the question number 4, we have right option is A. A is a right option for question number 4. Next, dear students, I'm going to proceed with question number 5. The extension of the material by itself without increasing the load takes place. So just observe here. Here I'm going to consider a specific material. In which suppose this is the material of length L. Here, in which suppose if you apply a force at its both ends, then what happen? It may produce a stress sigma, and even though it may produce a strain epsilon. Stress and versus strain. If you draw a stress versus strain graph, then you can easily understand. You can conclude the right options for this question. You have 4 options. That is the first one: within elastic limit, behind elastic limit, behind yield point, at breaking point. Suppose, dear students, if you draw the stress strain graph for a mild steel material, you'll get this graph. You'll get this graph. That means here from starting from O to A, that is a proportionality limit. Here the stress nothing but where we know that is force by area. The stress is directly proportional to load, as well as strain nothing but change in length by original length. The strain is directly depends upon, I mean directly proportional to change of dimension. Here change in length. Here, as the force applied, the stress value is go on increasing, even though the material may strain taking place. In this condition, till the point C, as the stress increased, even though the strain also increasing. Once if it reaches the point C, without increasing the load or without increasing the stress, the material is straining. I mean, straining action is taking place. That means it increasing its dimension. Just you can observe here, dear students, at from a point C, at this point, it's not increasing its stress, but it's increasing the strain. It's not increasing the stress. You can observe here. It is decreasing, but it's increasing its strain. So we can once again you can conclude that the extension of the material by itself without increasing the load takes place. I mean that after the point C, there is no, it's not taking any load, but straining action is taking place. The material ಏನಾಗ್ತಿದೆ strain ಆಗ್ತಿದೆ. That point ಗೆ ಅಂತ ಕರಿತೀವಿ ನಾವು yielding point, upper yield point. So for these questions, C is a right option. See, behind yield point, the right option is C. Okay, dear students, next I'm going to proceed with the next one. Question number 6. If the strain in a wire is 0.1 percentage, strain in the wire is 0.1 percentage, then the change in the length of the wire of length 5 meter is. Dear students, first of all, if we know the strain, what is the meaning of strain? First of all, strain nothing but usually we are going to denote it by later epsilon, that is change of length by original length. Here in this question, the strain of a wire is 0.1 percentage. The 0.1 percentage means 0.1 into percentage, that you need to convert into fraction, that is 1 by 100 is nothing but 0.001. Next, of a length of L of a material wire, that is 5 meter. Next, dear students, we need to find a what is change in length? Change in length means that is delta L. So delta L nothing but change in length. That we need to find. See, we have 4 options A, B, C, D, in which we after the solving only we can conclude that which is the right option. So first of all, the length of the wire is 5 meter. The strain in a wire, that is 0.1 percentage, nothing but 1 by 100 into 0.1. This you can consider as 0.001. Next, we know that strain nothing but change in length by original length, or else we need to find a change in length. So therefore, strain into original length. Change in length equal to strain into original length. What is strain here? What is strain here? That means change in length I'm going to consider as delta L equal to strain is epsilon into original length is L. The strain nothing but that is 1 by 100 into 0.1 into length of the wire is that is 5 meter. That is 5 meter. So finally 1 by 100 means 0.01 into 0.1 into 5 is nothing but 0.001 into 5. So nothing but this 0.001 nothing but we can written as 10 to the power of minus 3 into 5. So finally 5 into 10 to the power of minus 3 is the right option. That is your change in length in meter. Change in length in meter. This is the right option, dear students. Just you can observe here. Change in length is 5 into 10 to the power of minus 3 meter. In the question you can observe here option B. B is the right option for question number 6. Dear students, these are some of the questions they asked from the chapter 2, that is properties of solids and liquids in science syllabus. Dear students, for more details and more materials, you can get our material from Triple T publication, even though this is available in Amazon as well as Flipkart. Thank you for watching this video. Dear students, please share with your friends. Subscribe our channel for more videos and classes. Thank you all.